Same-o, me say same, me say same, me say same-o. The statistics test has the same standard deviation, so it may not surprise you that while this is our hypothesis test, the confidence interval is going to be the same equation here, where we have our difference in x bars, our t-score, and here this piece has the same pooled standard deviation that we've been doing the whole time. Let's look at an example. We're going to look at the soil in College Station and in Bryan, and they're so close together maybe we think the soil's basically the same in each of them. We're measuring porosity, that's how easily water soaks into the ground. That's important if you're concerned about flooding or laying pipes under the ground.
You're sinking! Come on! Turn around! You have to now!
Those sorts of things. So we have our data. Is it matched pairs? Was there something about the first location tested in College Station that matches the first location tested in Bryan? Not particularly. We could come up with an example for that, but it's not matched pairs, which means that number there is completely worthless. I don't even know how they got a standard deviation for the differences when the sample sizes aren't equal, so not matched pairs. It is going to be a pooled test because it says right here, College Station has the same standard deviation as Bryan. So the first step I want to do is to find a pooled standard deviation. And when I'm done, I always do a reality check because I plugged in my calculator, but maybe I messed up. 3.14, is it between these two standard deviations? Yes. Is it a little closer to the 54? Well, these two sample sizes were awful close anyway. So yeah, this seems realistic. And if you mess up on your calculator, you'll often get a response here that's just ridiculous. Once I have this piece, the rest of this is going to feel just like we were doing that independent two-sample confidence interval. Take the difference in means, and now I need my t-score. What's my degrees of freedom? 45 plus 54 minus 2, which is going to be 97. I'm looking for a 92% confidence interval, so I have 8% in the tails. One tail is going to have 4%. There's my t-score. And now the same error structure, but using this as the pooled variance. I'm calling it variance because it's the standard deviation squared right here. Calculate this out, and we get negative 4.5 to negative 2.33. It might seem weird that we got negative numbers, but remember we're taking one group minus the other group. So a negative value indicates the second group was larger. That means Bryan's soil had a higher porosity level. How much higher? Somewhere between 2.3 higher and 4.5 higher. Had we switched these groups around and done Bryan minus College Station, then we would have had positive values, but it would have been the same numbers and it would draw you to the same conclusion. Is Bryan Station and is the soil in Bryan different than the soil in College Station? Yes, Bryan is higher in porosity, 2 to 4. So clearly the statement where I said that they were going to be the same wasn't valid. And I hope you noticed something I kind of glossed over. Why did you think the standard deviation was going to be the same if you thought perhaps the means were not?
Why would you say that?
Just had to consider it once.
That leads us to this idea of which of these four scenarios is really the most realistic. We could do a hypothesis test with an independent test or with a pooled test. We could do confidence intervals with an independent test or a pooled test. The assumptions that you're making matter. We're testing whether mu1 equals mu2. For the independent test, we're saying, but those sigmas aren't the same. For a pooled test, you're saying, yeah, the mu's are equal and the sigmas are equal. I think the two groups are altogether equal. So this makes a lot of sense. On the other hand, confidence intervals, you know the means are different and you want to estimate how different are they. I want to look at the difference between mu1 and mu2, and let's say those two groups are very different. A pooled confidence interval says, I want to look at how different those means are, but I think that they should be connected or tied with the standard deviation. Why are they tied at the standard deviation but not at the means? Are they separate or are they not separate? In other words, if we're talking about a hypothesis test, the pooled version is the most realistic. If we're talking about confidence interval, then the independent test is going to be the most realistic. However, for this class, all four scenarios are things you will be expected and asked to do, and it's really not so bad because once you know how to do one of these hypothesis tests or confidence intervals, then it's pretty simple to do the other one.